Hello everyone, welcome back to this data science learning series. This video is just the continuation of my last video where we talked about simple linear regression, and today we will develop a model of type multiple linear regression. As you know, multiple linear regression is just an extension of simple linear regression जहाँ पे कि हम लोग के पास multiple independent variables होता है और एक dependent variables होता है. So just to give you a brief recap of linear regression. So if you remember, this was our formula for our simple linear regression where y equals to a plus bx. A was our intercept and then b was the slope of the line which we had. And then here y is nothing but the value which we are going to predict. We also call it as a dependent variable, and then x is our independent variable that against x we want to predict the value of y. Now coming to the multiple linear regression part, where the formula changes a bit here. If you see, the formula here is like y equals to a plus b1 x1 plus b2 x2 plus and until bn xn. So how many independent variables you have? Based on that, we will be calculating all the slopes for each independent variables and then adding all of those with the intercept. Then we can find out the dependent variable, which is nothing but the output of from our model. So for example, let's consider that we are going to predict the price of a house based on multiple independent variables. So maybe one independent variable could be the size of the house, the another independent variable could be the location, and then the number of bedroom could be your third independent variables. So here if we try to fit in these independent variables in this formula, so here x1 would become the size of that house, x2 may be the location, and then xn may be the number of bedrooms that house has. And considering all of these independent variables and their slope, so for each line there will be a different slope, we are going to add all of those with the intercept, and then we'll calculate the dependent variable, which is the price of that house in this particular example. Alright, so now let's understand this particular formula in this particular chart which we have here. Here what we have done is, let's consider that we have two independent variable. One is that house ka size, then second one is the number of bedrooms, which is again our independent variables. So let's consider if we have only two independent variables, then the formula would be y equals to a plus b1 x1 plus b2 x2, since we have only two independent variables. And if you see again, the slope would be nothing but the angle on which the line is drawn. And for each bedroom apartment, let's say if it is a 2-bedroom, then this will be a regression line. If it is a 3-bedroom, then this will be a regression line. This will be for 4th, and this will be for the 5-bedroom apartments. This is going to be a regression line, and their corresponding slope would be considered as the b2. So then considering this intercept b1 x1 on the slope of the house ka size price, and then b2 x2 the slope on the number of bedrooms which we are going to pass, on that what could be the slope. And using all these things, we will be calculating the dependent variables, which is nothing but the house price in this particular case. Alright, so now let's see what are the differences between the simple and then the multiple linear regressions. So like I mentioned, in case of simple you have only one independent variables, whereas in case of multiple you have multiple independent variables. This is quite simpler, whereas in multiple it's a little complex compared to simple linear regression. And this was its formula where you had y equals to a plus bx, whereas in case of multiple linear regression the formula becomes a plus their corresponding slope of each independent variables and then addition of all of those. Okay, so having said that, now we will be moving towards building the multiple linear regression model for the same house prices which we have built for the simple linear regression. So in simple linear regression, what we had done is we had just provided the size of that house and then we were finding out the price of that house. Whereas in case of this multiple linear regression, we will try to provide few more inputs, few more independent variables, and then try to get the output of that house price. Okay, so I hope now that you have a clear understanding of simple and multiple linear regressions and their differences. So now we will move towards building the multiple linear regression model for predicting the house prices based on the size, number of rooms, and location. In our last video, what we had done, we had built a model which used to give us the house price based on the number of square feet which that house had. But today we'll increase this complexity of this particular model, and then we'll include all three different independent variables which we have. square feet, number of rooms and location. Using that, we'll try to predict the house prices. Okay, so before moving on to this coding part, I just want to also give you a quick overview of our dataset which we have here. So this is again a Bangalore house dataset which I have downloaded from Kaggle, and this was the different columns which are present in this particular dataset, which is like this is the area type, availability, location, size of that apartment, which society is this from, total square feet, total bath, total balcony, and what is the price. So definitely this is looks like some 5-6 years old dataset, क्योंकि अभी तो 39 lakhs में बैंगलोर में कुछ नहीं मिलने वाला है, but then again we have this data set and we'll try to kind of train our model based on this data set. So coming to the coding part, so the very first thing, like always, what we'll do is we'll import all the necessary libraries which we need for building this model. तो स्टार्ट करेंगे पांडा से. वी हैव टेस्ट ट्रेन स्प्लिट, जैसा कि आपको याद होगा कि दिस बेसिकली स्प्लिट योर डेटा सेट इनटू training set and then testing set. And again from sklearn we will be importing this linear regression model which is already on built, which already has all the formulas inbuilt in them, and we'll just be using that. We'll also use this label encoder. I'll tell you what exactly is this in little later, but then all the other things like mean squared error, r square value, and then matplotlib, seaborn, all of these you already know, and we'll be importing all of those in our this particular data set or this particular Jupyter notebook. So now this Bangalore house data which is there in this CSV form we will load and see what are all the top 5 values and how those value look like. So if you see area type, availability, location, size, and all of these are there. And if we have to, let's say, find out how many number of records which we have, so we have df.shape function. If I run this cell, there we'll find that around 13,320 records are there, and then 9 different columns are there in this particular data set which we have. If I click on describe, so again we'll get all the statistical value of all the kind of numerical columns which we have. Key, what are their count, what is their mean value, standard deviation, minimum 25 percentile, 50 percentile, 75 percentile, and what are their max values for each of the different all the numerical columns which we have. So let's say in one of the apartments there are some 40 bathrooms which are there. So again we'll have to clean this data as well, because we'll see, like when we go to the next section, there we'll see how do we clean, how do we pre-process the data set before building our model. So this was just that basic overview of our data set which we had. So now we will move to this data cleaning and preparation of this data for our model training part. So as many people say that your model is going to be as good as your data, so we are going to do this data cleaning step so that we don't have any inconsistent data or any inconsistent rows in our data set, so that our model also performs the best whenever a real-time data set is given to that. So the very first thing what we will do is we will list on all the columns which we have in this data set, and these are different columns. So if you remember that key, what we do is we are going to predict the house price based on square feet, number of rooms, and location. तो बाकी का जितना भी columns है we'll try to also drop them. So let's say we are not going to use this area type, we are not going to use this kind of society and balcony. So what we'll do is we'll simply drop these columns by making use of df.drop, pass all the columns which you want to drop from axis 1, and then all the columns will be deleted from that particular data frame which we have. So if you see, now we have only availability, location, size, total square feet, bathroom, and then price. Okay, so now after this, let's also see whether there are any values in these these columns, whether any values are null. If there are any values which are null, I'll drop those values as well, because anyways these null values are not going to make any difference in our model training. So what we'll do is simply make use of this df.drop na and then write df.shape. Then you'll see from earlier we had some 320 records, 13,320 records, that has converted to 13,246 records, which means around 80 records where null values were there in those 80 different rows which we had. Alright, so now let's clean the columns which we are going to use for our model training. So one of the columns which we will be using is this total square feet. But if I show you our data set, so here if you see somewhere you have some square feet in the range, right? So you have hyphen in between. So all of these will cause an issue in our model training. So what I have done here is I have written a function which will convert this particular square feet into a float, and in case if it is not getting converted, what we'll do is we'll take this hyphen out and if we find this hyphen in any of this x, what we are going to do is we are going to take the average of these two values, so that this, let's say if it is 3010, 3410, so we'll calculate both of them, add both of them and then divide by 2, so that we have a average square feet for that particular house calculated. Okay, and what we'll do is we'll try to also run this cell, and then once we do that, and then we'll see that there were also some null values as well in the square feet, and that's when we got that now the shape which we have is around 13,200 records which we have, with six different columns which we have. Another column which we are going to use for our model training is this size. So here also what we'll do is we'll try to remove all these string values from this, so that machine learning models understands all this only the numerical columns, and because again string values ML models will not be able to understand. So that's why what we are going to do is we are removing all those values, all those strings wherever BHK or bedrooms are mentioned, and for that we have this particular formula to convert this BHK our bedroom, and then return you only the first part of that. So if I do this and kind of also add another column which is a BHK column, and there you will see this 2 BHK got converted to only 2.0, 4.0, 3.0, 3.0 and 2. So like this, what we are doing here is these are all the different steps. Depending on your data set, we'll have to first clean the data set which we have and prepare the data set so that it becomes ready for our model development. Okay, so now we will move to the another ways of cleaning the data which we have. So what we'll do is let's find out for each location how many records are there. So if I run this cell, and there we will find that from the white field we have 532 records, whereas for the locations like Subramanya Nagar, Malur, Hosu Road, Abshot layout, we have only 1 or maybe 10 or 20 records which are there. So again, with all this location keeping in mind, and then some location with 500 records, and with some location only 1 or 10 records, again the model imbalance will come. So that's when what we'll do is we'll try to find out all those location where the location count is less than 30, right? And then we found out around these are the different locations which we have where you have less than 30 records in your data set. So what we'll do is we'll simply remove these locations from the data set, because again keeping all these locations separately, and again keeping other locations separately, again the model might not be able to distinguish between different locations which we have. So what we'll do is all these records wherever you have 30 records, we'll keep the location as others, whereas rest all location will keep it as it is. All right, so what we are going to do is here locations wherever we have more than 30 records, we'll keep it as it is. Wherever the locations where we have less than 30 records, we'll combine all those records and then keep it as others as a location, so that we have a proper data balancing between the different locations which we have in this data set. So again, if I run this cell, so now we'll find that we have now around 97 unique location where along with this others as well. Alright, so now let's move on to the next section, but before that let's see now how our data set looks like. So you have electronicity phase 2, but then the kind of the previous location got converted to others as well, and that's when we have only 97 unique locations, and all of those will have a good number of count as well under their name. So if you remember, I was mentioning that ML models only understand numerical values, but if you're going to define a location as one of its independent parameters, then we'll also have to convert this particular column into numerical. But now how can you convert this numerical, basically this string into a numerical value? So that's when another function which is label encoder. So if you remember, initially we had imported this label encoder from sklearn.preprocessing. So here what basically this label encoder does is for each unique location it will provide a unique label, and that will be in terms of numerical values. So let's say what I am going to do is I am going to convert this particular label encoded to basically use this le.fit transform and pass the column for which we want to provide the label in terms of numerical form, so that our ML model understands. What I'll simply do is we'll run this cell, and then if I run the df.head, so there you would see that this location got encoded to this particular encode. So wherever you will find this electronicity phase 2, it will always be encoded to 25. Same way this particular others will always be encoded to 96. again, if you see again the other here, you'll also have this other 96. So instead of manually doing all this kind of encoding, we have made use of this label encoder from sklearn to provide the encoding for all my string column which we have. Same way we also have this availability column, so all of these are ready to move, or maybe some availability date, so those will also get converted into a different encoding, and there we'll see that all this ready to move got converted to 79, 79, 79, 79, and all of those 19 December would have been converted to this 40 encoding. The reason, again repeating, because ML models only understand numerical values. So with this, we have almost completed the data preparation step. But before saying that, let's visualize our data and also see if there are also outliers in the visualization. Then we'll also try to remove those so that we have only the correct or maybe good data set which we have, which is that where we will be training the model. So let's visualize our data set based on the total square feet and then the price which is mentioned here. So if you see here, key between 0 to 100, maybe 0 to 1000 square feet, we have most of the data set, whereas some also have some 5000 square feet as well, and as well as some in the more than 3.5 crores house as well. So what we'll try to do is we'll try to consider only this data set, because if we are going to train our model only with this, and what we'll do is we'll remove all these outliers which we have, because there are very less records in the outliers, and this might critically affect our model's performance. So what we'll do is we'll take only this section of data set and we'll train our model based on that. So to do that, what we are doing here is give me all those rows where the total square feet is less than 8000 and then the total price is less than 1.5 cr. So if I run this cell, so now this got converted to 13,138 records, which was around some kind of 70 or 80 records which we have removed, which was part of the outliers. Then if I see now my dataset, then this dataset looks something like this. Earlier it was looking like this. After getting this particular thing, it is looking like this. So this again depends on you, that on what, based on your dataset, how your dataset is there. You have to basically consider only those data which are relevant, which are good, which are perfect, so that the model which you are going to train with that data also becomes perfect. So what we have done here is we have removed all those things, and then now our data sets look something like this, where I see the most of the data set are in the similar ranges. Then let's see based on the BHK, how many number of bathrooms which we have. So again, things are almost the same, but then I see for some apartment there are some 40 bathrooms, for some there are some 20 bathrooms. Again, these look like some outliers in the data set. So again, what we'll do is we'll remove all those records wherever the number of bathroom is less than or maybe more than 10. So again, some are again 30-40 records have gone, and then if I run this cell again, so now the data set looks perfect. Ki, number of bedroom pe hi you have number of bathrooms, and then all of these values look corresponding to each other. Then now we are moving to the step number 5, which is the model training part. So before model training, again, if you remember, we will be doing the splitting of data. Whatever the data which we have, this 13,000 records, we will split this data into trained data and then the testing data. So again, to do that, before doing that, what we'll do is we'll first define X. So all this my independent variables. So total square feet, BHK, location encoded will be our basically the independent variables. So 3 independent variables, and then I want the Y as an output, which is our dependent variable, right? And then we are converting this data set into X train, X test, Y train, Y test, using train test split, which we had imported via this sklearn. This was the import which we had done initially, right? So what we'll do is we'll simply kind of split the data set into X train, X test, Y train, Y test, and the test size as 0.2, which means 80% of them I'm using as a training data, and then 20% I'm using as a testing data. So again, this numbers also you can change based on the model performance later. Then we will be building the model. How do we build the model? Simple thing is we just have to define model equals to linear regression, and this linear regression again we had imported via sklearn, and then pass X training and Y training as an model.fit parameter. So if I run this, there you go, our model is now ready. So to evaluate our model, we'll see what are their coefficient values and what are their intercept values. So we found out that these are the different coefficient which we have, and then the intercept is at 84.27. That's when the intercept happens. Okay, with this now we'll also try to make the predictions on the testing data, and then also later we'll try to visualize the data. So why prediction, what we are doing is we are passing model.predict and passing all those x test values which we had separated out from our initial data set. 20% of this data set is kind of stored in this x test, and that's when we are asking the model to predict all those 20 values which we have not yet seen till now, and then kind of store all those prediction values in this ypred parameter and show me top 5 ypred and ytest. So actual values were around 170, and then the predicted value came around 94, and for some 70, 73, 55, 85, 100, 123, 150 was the actual value, and then we got a prediction of 122. So basically I see model is not that good, but then again in the similar ranges given the data set which we had, we tried to kind of train our model. So what we can do further here is to improve the performances. Maybe what you can do is you can try to increase or decrease this test size. You can also try to provide some more independent variables like availability index, or maybe number of balcony, society. So all those kind of things we'll try to provide as an input, and then find key whether there is any improvement in the performance or not. So but then before finally concluding on the performance, we'll also, if you remember that we had this mean squared error and then r square value. So which means this should be as less as it can be, and this should be little closer to one value. So if I run this, so what we have found is that 66,739 is the mean squared error, which is pretty high, I would say. And then around 54% is this r square, which means ki around 54% times the model is performing good, whereas for the rest of the kind of 46% it is not performing that good. So like I mentioned, now we'll have to go back and then retweak our model in a way so that we have a better performance done. So we'll continue with the same thing, and this will be the stretch goal for you, so that you tweak this model, and this particular, the entire code base will be there in my GitHub. You tweak this model, play around with this model, and then see if you are able to get more better r square values and then lesser mean squared error or not. So let's visualize this kind of result which we have predicted, and there you will see key predicted values are mostly in this particular range, whereas some values which we had in our data set were in the higher ranges as well. All right, so with this what we'll do is we'll also test our model, and to test our model what I have done here is I have defined a function predict house prices, pass the 3 parameters square feet, BHK and location, and then return the predicted price values to me. So let's consider that total square feet is 1832, 3 BHK, location Whitefield, and then let's find out what is their house price. So it is saying in Whitefield area 3 BHK house ka you will have 117, which means 1 crore 1.17 crore would be your house value. So what we'll do is we'll try to change the maybe square feet here, 1000 square feet and 2 BHK. And if I run this, then it says that around 40 lakhs you will be able to get 1000 square feet 2 BHK in Whitefield area. Similarly, you can also change the other location. So let's say I'm changing this to Uttarahalli, and then based on that you will have a different price of your house. So with the same thing, if I pass this as Uttarahalli, and there you will see around 40.722 to something like this, it has basically changed the value. So with this, you can basically play around with the model which you have trained, and also find out the prediction of the house prices of any given area, any given location, any given number of bedrooms, or any given total square feet of your house. Alright, so with that we have all built our second model, which is to predict the house prices based on the size, number of rooms and location. And I hope you all would have liked this video, and you all would have enjoyed while creating this model. So with this we are coming to this end of this video. Thank you so much for watching. Please don't forget to like, share, and also subscribe this channel, and also share this channel with your friends and family. Thank you. See you in the next video.